Righto, it is calculation time. And here's our question. We've got 0.4 moles of zinc are reacted with 1 mole of chlorine to make zinc chloride. So here's an equation for that reaction, right? We've got zinc plus chlorine gives us zinc chloride. And what you've got to do is, number 1, identify the limiting reactant. And number 2, calculate the mass of zinc chloride that's formed. I've given you some relative atomic masses down here, so those may come in handy, and a couple of little formulas down here which also may be handy. Okay, so jot this down, have a quick go, and we'll catch up in a few seconds to go through the answers. Righto, time to go through the answers. Now, for this question as well, it involves masses, it involves moles and that kind of thing, right? So I would start by setting up my handy table again, right? So I've talked about this in previous videos. Set up one of these whenever you've got questions involving mass and moles, okay? So you've got our table. Now look at the info we've been given. You have got 0.4 moles of zinc, right? So we can fill that in the mole section for zinc. So let's do that in a different color. Hold on a second. 0.4, there we go. So you've got 0.4 moles of zinc. And then we've got 1 mole of chlorine, right? So let's just highlight that as well. 1 mole of chlorine. So to fill that in the table as well. We've got 1 of those. There we go. 1 mole of that. And now the first job that we have to do is work out what's the limiting reactant. Now, a limiting reactant is the one that's going to be used up first, okay? Or you can consider it as the one that there's not enough of. Now, how do you identify which one is limiting? Well, you can do this, right? So I'm going to use just a rectangle. Let's just draw a rectangle here real quickly. Here it is. And what we're going to do is cover up just one of the species in your equation, cover up the moles for it, okay? So I've chosen to cover up Cl2. Now, why have I done this? Now think real carefully. Here we go. If we're using 0.4 moles of zinc, right? If we look at the ratios in this reaction here. So let me just shrink this down a tiny bit. There we go. If you look at the ratios here, the ratio, remember, is the numbers in front of the species. There is a 1 in front of the zinc and a 1 in front of the chlorines. So I can put a 1 here and a 1 here. What does this tell me? This tells me that 1 mole of zinc is going to react with 1 mole of chlorine. So the moles here need to be the same in order to react. Now, if I've got 0.4 moles of zinc, that means, according to my ratios, that I would need to have 0.4 moles of Cl2. Okay? So 0.4 moles. But if I pull this rectangle away, then, oh, what did we see? Well, we've actually got way more than 0.4, right? We've got loads of this because we've got 1 mole of it, right? So the fact that I've written loads there, this tells me that this here is in excess. It means there's lots of it, which means the other chemical, so zinc in this one, is going to be your limiting reactant, okay? So that's a handy way to find out which is your limiting reactant, right? Take a little rectangle or something, or just cover up the other species, work out how many moles you would need according to the other one, and then if there's loads of it, it means it's in excess, okay? Just as we did there. Perfect. So we've got our limiting reactant. Our limiting reactant is zinc. So I'm just going to fill that in here. There we go, Zn. Now we can get rid of this rectangle. And the second thing we need to do now is calculate the mass of zinc chloride that is formed. Now something super, super important is this. Listen very carefully. Because this here is in excess, you do not use it for any of the further calculations. Okay? So cross it out. Make a note of that now. Okay? If you use that for the rest of your calculations, you will get the thing wrong. Okay? Why? Because there's loads of this. This is not controlling your reaction. This is controlling your reaction because it's going to be used up first. Okay? Now, if there's 0.4 moles of this, we look at our ratio numbers again. The ratio over here is 1 as well. So I'm just going to put 1 over here. And that means I can put 1 into my ratio box here. What does that tell me? That tells me, well, the number of moles here must also be 0.4. And now we need to find the mass, right? So we've got to get this question mark up here. So we need to work our way up the table. We need the MR of ZnCl2. We've got the info here for it. Here we are. So for Zn, that's 65. And we need 2 lots of Cl, right? So Cl2, that's going to be 35.5 times by 2, which I think is 71. So we add those together, what's that going to give us? 136, isn't it? There we go. And now to find mass, well, we'll need to just rearrange this formula here, right? Mass is equal to moles times by mR. So then we can do 136 times 0.4, and that comes out as 54.4 grams. And there we go. So that's the answer that we were looking for there. So vital things to take from this is that method to find your limiting reactant, right? Cover up one of the species, think about how many moles you would need to make it, and then take the rectangle away and see if you've got loads more than that or not enough of that, okay? There'll be more examples of this soon, so you can check it out and test if you actually understood it. And the second important thing is, once you've identified which is your limiting reactant, and which is the excess one, cross out the excess one. You don't need it for any further calculations, okay? You use the limiting one only. So hold on to that, store it in your brain, and we'll catch up again for another one of these questions very, very soon.